One of the interesting things in terms of my role is that I've come from a pure chemical background, so I'd had nothing to do with biology or anything. So I had 24 years and 150 agronomists that were all very focused on production by just adding chemical product to the production cycle. So only last year, I guess I'd just seen a number of growers where they'd been continually doing the same thing and yields were going backwards. So we started to really pull apart, how can we do something different? And I guess for all of us, if I came from a farming background in Western Australia, and if we actually think about it today and say, where will your soil be in the next 10 years? And where will our soil be for the next generation? It's really around what do we need to do differently to actually change the tipping point in the ecological basis of how we're going about our farms. So I've been really excited to start doing some work with people like Rod and Bruce. And part of what we want to go through today is really to just demonstrate the practicality of how you can start to migrate between the two systems. And certainly in my previous roles, if someone had come in and started to talk to me about biology 5 years ago, I don't think they would have even got a coffee. And that's really what we're trying to deal with in the industry in terms of us as producers. How do we actually develop and change the systems to be more profitable? So LawrieCo actually started out of a farmer's passion from Port Pirie, a man called Adrian Laurie, who's with us here over there today. Adrian, if you stand up. So Adrian realised the challenge of farming and 25 years ago started to study biology and what he could do to bring that in. So I won't take up any more time. I really want you to talk to the people that are practically doing it and have had on-farm experience to get the results. So I'll hand over to Rod.
Oh, thank you, Matt. Okay, so everyone's expressed the importance of carbon within systems and the progressive decline in carbon, and with that, the decline in soil biology as well. I came from a horticulture background where carbon inputs, biology inputs were a lot more prominent than what they are in broadacre. And it was at that time that I started to look for products and alternatives that could be used in broadacre cropping as well, and at that stage came across LawrieCo. We work on very simple strategies, and that is to try and maintain balance in soil biology, trying to build soil carbon. It's not always easy, and every situation is very different. So currently I work across sort of 3 states and a couple of other states on the phone, and every customer and every person I speak to has a different situation and requires different inputs and is using different machinery for different crops, and it's not always easy. It's not always easy to get the products and principles across without a lot of additional work or without a lot of additional costs. So we've developed ways that you can fit microbial inoculants, biological enhancements into current programs. One of those things, Matt will mix up some fumate prills in some water and sort of give you an example of that. So coming from the hort game, there was humic acids. Everyone's familiar with humic acid in the room, I would imagine. You're talking about the concentrated active ingredient of compost. So once you can extract that and then utilise that, the quantities that you need become a lot less, still giving you a lot of the benefits that bulk composts and organic matter give you. So we work on some basic principles. So we first look at mineral balance, and there was a bit of discussion about pH and porosity of soil and whatnot. So that all starts with mineral balance. There are some things you can do there to improve that and enhance that. Then we look at the microbial ratios between bacteria and fungi, and due to chemical inputs, basically chemical fertilisers, fungicides, insecticides, the ratio between fungi and bacteria has been thrown out of whack. So where we should have fungal dominant soils, generally speaking now we have bacterial dominated soils. Simply fungi are the driver for building soil carbon, and bacteria are a driver for consuming soil carbon and breathing it out as carbon dioxide. So as our as our soil carbon goes down, our microbial balance gets more and more out of whack, and the further you go into that process, the harder it is to repair. So by adding microbes, by adding humic acid, by adding fulvic acid, and incorporating all these things in as many different functions as possible, and getting bits and pieces into the system, we can buffer a lot of those toxic effects that you get from the chemicals that we're using, and we can supply the microbes with the food source that they need. So that's that. Where are we at here? Okay, the slides aren't really relevant to what we're saying. But, okay, so as far as practically applying these products to any agricultural situation, we look at inoculating seed, we look at inoculating seedlings, and then even in established crops, we can look at inoculating the soil through fertigation and whatnot, and then including carbon sources, humic acids and fulvic acids in with the chemicals to further buffer that toxicity and supply the biology with a food source. There's been a bit of discussion about residue management and stubble management, how you go about incorporating that back into the soil and getting the most from it. Often a lot of people I work with have gone solely to cropping and they run no livestock. So one of the other speakers was saying if you had a phone number and you could just bring the cattle in, that's one answer. But we look at other options. So you can actually spray a cellulose digesting fungi onto the organic material to break it down. So where you've got bacterial dominated soils, and then you lay your organic matter onto the surface, the bacteria do a lot of the work of breaking that down, and a lot of that carbon's lost. Whereas if you can inoculate with fungi and get the fungi to do the work, you can actually bring a lot of that carbon back into the soil. So another common question that's asked and was sort of raised in the last presentation is the economic return. There was a DPI trial which was run completely independently in Horsham, which is up there now. So you can see there that the biologic fertiliser or biologic treatments yielded very well. And then if you look at the blue graph, the return on nutritional investment was actually the greatest with biological treatments. So just very simply, if you can get the soil working for you, that's where the money is. And I think everyone in the room, it's about making money. This slide here just makes a comparison against single superphosphate and a biological fertiliser. So the big difference is instead of just putting out a few minerals, you get a lot more. You get your trace elements, you get a much more balanced array of minerals, as well as humic acids and fulvic acids and organic carbon to stabilise all of those in the soil. Bruce will talk to you about that further. So he's had a lot of practical experience using those products, and you should be able to see from his presentation what the benefits there are.
Look, one of the biggest difficulties I know when we looked at this 10 years ago was that we knew our soil wasn't performing, our cattle weren't growing as well as they should have, the grass wasn't doing what it should. We were just plateauing along, so we looked for something different. I was lucky enough to come across LawrieCo, and a young fella there, Ryan Walker, was there at the same time. So we started off on a 3-year trial basis because, like all farmers, there's bottom dollar. If you can't make money out of it, you can't be in it. So we set about trying to work out our weight gains. We had control groups. Every time we did anything, we always had a control to go back to. We went back to the basics of just looking at and measuring. The first day we did this test was water infiltration and using the panometer. It took us something like 6 hours to get 25 mils of water to go into the ground at Avenue. So we knew most of our water was running down the drains and not being used. Within 3 years, the second year we saw a huge difference in actually the water infiltration. So basically, if you can get water in the ground, you're going to grow grass. So that was the first step, and then we started monitoring. We were doing tissue tests on our cattle, tissue tests on our pasture, and down to the simple parts of the water penetration. You can see, I think the next slide's gone up, is how we could see with the new and the old. That was a control paddock against the new paddock, and I think that was taken, oh, there it is, it's taken in January. So if you can grow green grass into January, there's dollars. It's not rocket science. And this is what we tried to do. We tried to prove, we were proving it to ourselves, having field days, doing everything else. But when you can see it as easy as that, it's working. A lot of our measurements were using bricks readings. I'd never used a bricks machine, didn't know anything about it. We worked on that, just to see where the sugars were in our grasses. It's not that hard. It takes you 5 minutes just going around. You go home, you do your oranges, you do your apricots. Hey, the sugars are up. It's a good time. So none of it was hard. It was an easy transition, and it sold us after the third year. We were sold on it, and it's the basic philosophy, and it actually gets you thinking. And it's like this morning, thinking and listening. I've been out of the country for 4.5 years, and biology was a long way away from us where we were in Kazakhstan. But it actually gets you thinking on the whole way, and it's what we eat. I'm not a good example of that because I like the bloody stuff that the barley growers use. But the cattle nutrition, we stopped having to use so many needles. We were needling multi-min, B12. We reduced a lot of that because they were getting it out of the soil. So fix the soil up and everything else goes with it, and including the bottom line. I don't know really what else I can say. And it's, the last slide, I think, this last slide, I'll bypass the last one. This is an example of just working together. It was all it was. It was Ryan, who's on the left, and myself and Pete Davo came along later on. But it was just working and sharing the information and gathering it and not making it too hard. Life's hard enough as it is. So the more simplicity you've got, the easier it is. So I think that's all I've got to say. I'm a bit of a trial person. I've actually got to make things work. When you work for someone else, you've got to make the bottom line pay. If it doesn't pay, I don't have a job. So that was some more trial work, pasture work we were doing at the same time at Avenue. We mostly trialled about 7 different pasture species to see what worked, and that one was our final outcome, and that's a bit of fescue, a bit of phalaris, and some chicory in there as well, and a couple of cloves. Things have changed a lot since then. Because, as I say, this trial work was all done nearly 8-9 years ago, because I've been out of the country for 4 years. And look, I can tell you now, last year I wasn't around at fertiliser time. The first fertiliser oil that went in has already gone, and it's being ready to be spread next week. Yeah, basically, as the plant's feeling it's healthiest, it's going to beat off the red-legged earth mite itself. You don't have to go worrying about putting chemicals. I'm not a chemical lover, never have been. So anything we could do, and down to the stage of knowing when it was the right time and the best time to cut it for hay, instead of looking at it, use a bricks meter and know where your sugar levels are. So it was a time that it was actually good, because I was getting a lot of education out of it as well, knowing when our plant was at its healthiest, when it was down, when it was susceptible to insects, and it's a bit of a contrast. I was sitting talking with a chap before, and the old theory was we used to put how many bits of pea on how many N, and we'll grow some grass. Well, that doesn't happen anymore. You've got to have it healthy. So you can keep throwing things at it, but at some stage you reach the peak and you just plateau.
Ideally, you need some moisture in the soil to wick up through the straw. You need to get the straw in contact with the ground to get that to happen. Then the bugs go out with the food source as well to limit that and to give them the best possible start. Once they colonise, They're very hardy, and the results we get are amazing. So 7 and 8 tonne wheat crops, straight back in with a tine machine the following year with no block-ups. So the straw loses all its integrity and just breaks up very easily after that application. So we use the microbiology lab, Ash Martin, which is going to speak later, so that they can do tests to give you those sort of ratios and what bugs there are. So we definitely look at that, but in general, everything that I deal with, whether it's horticulture or it's cropping, anywhere that's had intensive fertiliser applications and fungicides and insecticides, it's just completely out of whack. So less than 1-to-1. So we'd like to get it back up and be fungal dominant. So that question was, have I had any experience with sand over clay soils? Yeah. Yeah, look, we have. And a lot of paddocks you work with, the variation's just huge. You'll have some areas that are sand over clay, then you'll have some clay outcrops and some stony outcrops and everything else. I guess the hard bit is when you get variability like that is how do you address it easily? And the best results I'm seeing are through building the biology. So I've had a lot of practical experience where we had paddocks that had clay soils and sodic soils and calcareous soils and sandy rises all in the same paddock, and through the use of humic acid and biological inoculants and some foliar sprays just completely turned them around in one season. So I haven't had any experience really with clay spreading. I've been to properties that have done it and they're happy with it, but just purely using biology and a food source for that biology and carbon seems to make massive differences. Okay, so look, I work with a lot of soils that have a pH that's just fine, and a lot of farmers that are just adding chemical fertiliser. And then we go and we use biological-based fertilisers and we build carbon for roughly the same cost as what their chemical inputs were. Their yield increases, the quality increases. With perishable crops, increased shelf life, and we start talking weeks of increased shelf life for table grapes, for example, at the moment that we're working with. So the economic return to get away from just using chemical fertiliser, or at least trying to buffer that toxic effect and reduce leaching and reduce lock-up through the addition of carbon, it definitely has a place and it has an economic return.
Thank you. So what about time lag between, when you start embarking on, well, I'm not going to be chemical anymore, I'm going to use the biological additives. What sort of time frame would you expect your yields to be back to where they were when you were using chemicals?
Look, that's a difficult one. So basically it comes down to cost, how much you're willing to put in to how quickly you can do it, and how degraded your soil is before you start. So using different products or combinations of different products can speed that up, but then it becomes more costly, so the more refined it is. So if you use a high humate lignite brown coal with biology as opposed to using soluble humic acid, for example, it's a lot slower, but it's a lot cheaper. So in broadacre, we would tend to use cheaper products and do it more slowly. In high-value horticulture crops, we would tend to use a combination of products. So high humate brown coal biology and soluble humates, and then say we were trying to address magnesium, we might use magnesium oxide in conjunction with magnesium sulfate, just so you've got some quick release product and some slow release product. So look, it comes back to the economics as to how quickly you can do it. Yeah.
Okay. Yes.
Interject on that. We When we started our trials, we decided we'd have a go for broke scheme, so we were going to throw everything at it, and we weren't talking big areas. And you can spend a lot of money and see a lot of difference rather rapidly, but we decided to go, sit in the middle of the field, not the low input, not the high input, and financially it was as good as gold, and we could actually see a difference. So there is, when these blokes come out, I always say, give us a rich man scheme and give us a poor man scheme, and go in the middle, because there's different ways of doing it to achieve the end results.
Look, I don't know really the exact answer there, but what I could say is that, as some of the other speakers have sort of said before, is fungi is the key to being the sponge in the soil, to holding on to the nutrients, to building the carbon, to making everything plant available. So if you don't have the fungal content in the soil, you won't have what you would classify as healthy soil, and you're not going to have trace element availability and mineral availability like you should. So the more available trace elements and minerals you've got for your plants that your livestock are eating, the healthier they're going to be, and they're going to be more resistant to all of those problems. So yes, I would say that the bacterial-fungal ratio plays a part in that.
When we did our blood tests, all our trace elements were all elevated from when we weren't, from our control to our biological system. So if all your traces are up, you're going to have less stress on the animal, and that's where everything comes in on stress. So if you can actually keep the animal in good, healthy condition from what it's eating, it should go part of the way to resisting any disease. It's like at the moment, you can go and run around, and if anyone's been selling heifers to the export to the Chinese in the last 3 to 4 weeks, they'd know that the buyer that was coming around, he was actually carrying a bag of multi-min with him, and he was injecting all the cattle with multi-min just to pick up all their levels, so at their critical time of stress, they wouldn't get a respiratory disease, which then they go and kick you out on. So, if you've got all those levels up to the right acceptable levels and not over the top, because it's all about the balance, then you've got to be one step in front of your next door neighbour.
Absolutely. So, and it goes the other way. So the people that are using more and more chemical fertiliser, the less efficient that chemical fertiliser is, because they're destroying the biology, and so they're finding they're going to have to, or they have to put more and more on every year. And then the people that have got, or working hard to build soil biology and soil health, definitely less inputs. And generally the inputs change as well. So once you start considering soil biology as your number one, not your number one thing, but as a really critical thing, then your inputs will change. So your forms of phosphorus will change, your forms of nitrogen will change, all of those things, so that they're not as detrimental to the biology.
I won't use pesticides, I don't like them. They do funny things to you. But look, we still use a fertiliser program. It has got RPR in it, and it's humates and everything else. Where I am now, we've never used it before. We've had to fly on synthetic fertiliser and then land-based. We're just changing around. Kangaroo Island's got a funny soil type. Tim Prance is here, and a few others that have dealt with Kangaroo Island, and it's a bit of an unusual one, and we also have issues with freight. That's besides the point. But so we're going in there, and the same. And we use Roundup, but if we go and use Roundup, we put fulvic acid in there. I can't even remember the rates, and you use half the amount of glyphosate. So we're not using as much chemical to do the same job, but we're just doing it a different way. So, basically our country is all, the P levels are all fine, but it's releasing it. And that's what we found a big thing at Avenue Range was we actually released a lot of the other trace elements that were being locked up, just getting your calcium-magnesium ratios in the right order. And that's what we're looking to do on Kangaroo Island with a lateritic soil, is do the same sort of thing. So, yes, to start with, we are using the same amount to try and keep your phosphate levels there. But it's a bit of a half-half. It's not going, you know, we must really sit in the middle and someone drew up a table of, you know, whether it was a natural or an organic or, you know, well, we must actually sit in the middle. We just use what we think's the best for us at the time.